Okay, let's explore. So this is basically Leo's write-up and Alex's idea as well, right?
To 0.
So can you explain what you're doing? So you have basically a sum is equal to x, yeah, and say it's not 0, yeah?
Sum is not 0. We
And then you
introduce
say
number
y, yeah?
Say y, then Alice, well, then Bob can do like,
So Bob
can
can
write down y, in which
x
case,
plus y or y, yeah?
yeah, x plus y and or y. If you write down y, then x becomes x plus y.
Yeah.
And then if you write down x plus y, then sum becomes x plus y, or that's 2x plus y. In the case when it becomes x plus y, your goal is to make x plus y 0. So
Yeah, so
y should be negative x.
So look at the cases, yeah? So this is a good exercise in logic, okay? Can you tell us what kind of cases there are? So the cases where things are forced, right? Is where you don't really have a choice but to write down. What kind of cases are there? So one of the cases obviously is if y is equal to 5, right? Yeah. That's a case. And x plus y is equal to 5. Yeah.
Then there's no choice but to write 5. But
Minus 10.
That's one of the cases, right? If that happens, then then what does that mean?
x has
Okay, so
X has
here's
to be
my
0, right?
here's my graph for the 10 situation. It's kind of weird.
Yeah, all right. Before
I
we get
think
to
it's
10, let's
possible.
finish the 5, yeah?
Right.
What are the other cases it could be?
What?
not make you
Wait, y equals 5x plus 5 equals 5x equals.
That forces you to write a 5, right? But that can't happen because that would make x 0, you know?
Yeah, so you can't do that. And then you do like the x plus y thing. So x becomes 2x plus y.
So x plus 2. So yeah, so another option is that the sum becomes 0, right? Yeah.
That 2x plus y is 0.
Yeah, so there's another option is that the sum changes to 0, yeah? And the sum is 2x plus y, right? Is equal to 0.
If the sum is then y equals 2x. And then wait, minus 2x. Then yeah.
So we can actually make both options have the sum equals 0, right? So here it'd be like x plus y equals 0.
Yeah, but then in the other option, so if Bob picks the other option, okay, so for the first one, if Bob picks the other option, which is to write down x plus y, then x just becomes 0 again. I mean, no, then Bob will just write down 0, which means that it's a loop, which doesn't work. So we have to go with the other one, which is that y is minus 2x.
Yeah, so we have a lot of cases, right? So we can either output 5 directly or create the sum being 0, yeah? That makes sense? So 5, y could be just 5, yeah? Or y could be 5, and the alternative is to make the sum 0, right? That makes sense? Or x plus y could be 5, and the other one gives you a sum of 0, yeah? But the other one is just x plus 5, yeah, y, yeah? That makes sense?
So in the case that y is like, okay, so in the case that 2x, that y is minus 2x, then if Bob picks the other option, which is to write down y, then y being minus 2x must be the target, because then that would just write it again.
Yeah, so look at this one. So this is the only interesting case, right? But y equals 5 and 2x plus 5 equals 0, okay? And this is what Alex was saying. So if you have 2x plus 5 equals 0, then 5 is going to be even, right?
But then 5 is not even.
Yeah.
So you can't do it.
So the question here is this a proof? Okay. So that's a very interesting question.
Cases.
So I would actually say like there's actually a fair chance that this is a proof. Okay, but so the one very interesting point was it wasn't enough of a proof to convince the marker to give the full marks. Okay, so in a practical sense, it's not a proof, if that makes any sense. Like it might have been too subtle for the marker to even detect that it was a proof.
Okay.
So but you know that could just be bad luck. But if you do have more time and more skill, you could prove it in a more elegant way that doesn't leave any questions, right? So for example, you know now it has something to do with parity, right?
Yeah.
Okay. So something about, and what is 2x plus y? Well, so you're kind of adding, you're maintaining the parity of y, right?
Yeah.
So you can somehow rephrase this proof in terms of Bob's strategy, right? It might be easy enough for someone to understand and not take a mark off. You understand what I'm saying?
So Bob's strategy. Let's see. I don't know how to do that. I just like, wait. So do we have to force? Wait, so the goal is to force to 0, or the goal is to force
Or
to
either, right?
0 or 5?
So either the goal. So there's only two things that can happen, right? Like in terms of basically it's the sum changes favorably, or the actual thing written is favorable, right? And the only favorable sum is 0.
And then the only written favorable thing.
There's 5, yeah.
Okay. X plus y equals 5, then if x plus y is 5, then 2x plus y must be, because then x is minus 5.
Hmm.
Wait, no. Then y is,
So in some sense, right? Like if we were able to prove if this was a correct proof, right? Okay, then what we're saying is we're basically saying that Alice can't ever force Bob to output any odd number, right?
okay, now I go into saying that's Bob's strategy. So Bob's strategy would just, okay, let's see. What would Bob do? So if Alice says any arbitrary number. Okay, so if Alice doesn't say an option.
Yeah.
Okay, if Alice doesn't say one of these options, then Bob just does whatever.
So can you see, like, we can consider the problem mod 2 essentially, right? So Alice basically either says 1 or 0, right?
Yeah.
To begin with. And then Bob just needs to react in a way that maintains.
Just needs to keep it on. I mean, even. Wait. Did I go on? Yeah, because it's 2. So the current sum can change. Yeah, because the current sum is, if the current sum is odd, then Bob needs to make it even. But then he can change that by picking one of the two, because it is odd.
Okay,
So
let's
it's a
just say,
self-fulfilling prophecy.
so let's say Alice starts with an odd number, yeah?
Yep. I mean, you have to.
If it's odd, then he can make it even. Wait, so there's cases. So if the sum is already even, then Alice either provides
So
an
yeah, okay. So you want which one you want to start with? Sum is odd or sum is even?
sum is even.
All right. So that's when Alice is 0, right?
Yeah. So if the sum is even, then Alice can either provide an odd or even number. So if Alice provides an even number, we're good. Because it's still even if you write down y. Well, if it's any of them. If it's even, they can do whatever it wants. If it's odd, then I don't know.
What is the even output could possibly be 0?
Wait,
So have you guys basically done it?
no.
The 5-1 or the 10-1?
5-1. We're doing the 5-1.
We've basically done the 5-1, but we need to look from Bob's perspective to make it
There's one, there's,
convincing.
there's one more step.
Why would you say that? I will ask you again.
I'm just,
Oh, he's just degenerating to his old ways. Ah.
Okay, so the problem is when it's even and Bob and Alice provides an odd number.
Yeah, so it starts even and Alice can provide an odd number, yeah?
Then it's supposed to be odd.
Yeah, which is fine, but only happens once, right?
Yeah.
And then the sum is even. I mean, the sum is odd now. And Alice can either say an even or odd number, right?
If the sum is odd, then well, Alice can always wait, and then Bob can always ensure it. Yeah, Bob can always ensure if it's odd that the next one is even, because there's a difference of x between the two, and x is odd, so it changes the parity.
Huh.
So if it's odd and Alice says even, then Bob should pick x plus y.
Oh, if it's odd and Alice says even,
Then
you can just pick the even, right?
pick x plus.
Yeah, just write down the.
Because you want to keep the
Yeah.
sum even, or do you want to keep the number you write even?
But keep the number you write even, then it can't be 5, right?
Yeah,
Ah,
it can
okay,
be
got it.
5.
So they just write the even number. But if Alice tries the odd thing,
And the sum will also.
and the sum's also odd, then just do write x plus y.
Then it'll be even, right?
Yeah.
Yeah.
And if it's even, then just
Even then either it will remain even or you
if it's even and Alice provides
Yeah.
odd,
Yeah.
then
the only way
You
it
have
will
to write
remain 0
odd.
is if it always says even numbers. So
Yeah, so when it's even, if Alice says
and you
odd,
no, you
Then
just
you-
keep
just-
it
then you
odd.
just
then you just keep it odd.
Yeah,
and
you keep
can't
the
play.
sum odd and the number you write even. I don't know, that doesn't make sense because then
No,
in
you
that
can let
case-
him write one odd number, because it requires 100 odd numbers. The
yeah.
requirement is 100. So
Yeah, so you just let them write one
let
odd
them
number,
write
and then
the
you're in
one,
that
and then
case,
they
yeah?
just can't play anymore.
That makes sense?
oh my god, you guys
I'm
did it.
confused. Wait, so
Yeah, you can let them write the one odd.
one.
Because once you get into here, you're always
Yeah.
even, right?
Oh yeah, because
So this one will get into there. Yeah.
wait, so if it's odd and then Alice provides an odd number, you write the
just-
sum,
Which is even, yeah.
and then you still are odd. The
The
sum's still odd.
The sum is even.
No wait.
Wait, hold on.
No, the sum is still odd because you just wrote out. an
Yeah, you
even
wrote one.
number.
Yeah, so it just loops.
So it always is loops. Okay, so you keep the sum odd and then the
You keep the sum
It's
odd and the
number
number
you write.
even.
even, and then it just works.
Yeah.
Yeah,
It just works.
it just works.
Yeah.
And as for 10, I
And if Alice
think
says an even number, you can just write the even number.
yeah.
Yeah, so that loops.
I don't know, but I think that
Okay.
you can just like straight off the bat waste one odd number to
Yeah,
go
yeah.
to the odd. and then you can just do whatever.
Oh no, but you don't have that choice because like Alice is.
Oh
choosing.
yeah, because it's
Yeah.
even. Yeah, okay. You don't
Yeah.
have the
So
choice.
okay, this illustrates a very important principle. Okay, so it's kind of like, so if you didn't know what the word elegance in maths meant, okay,
This is elegant.
then the elegance is maybe the difference between this argument and that argument. Okay, and while elegance shouldn't be something to lose a mark, in this case it actually cost, at least in the Sydney marking, you might get it back in Russia. Cost a mark because the marker didn't understand this argument. Okay, and so and I guess one reason it's more elegant in some sense is because you've realized all the odd numbers can't come out, right? And so the argument has to, in some sense, be elegant because it applies to more things, right? The more general an argument, okay, the simpler it has to be. That makes sense? Because there's almost nothing that applies to everything, right? And so trying to prove that you can never output an odd number, even though it sounds like it's a stronger statement, right? It's actually easier to prove because you only have to consider two cases now, odd and even. Yeah. Okay. So this is an interesting way to resolve this question because now it leaves the door open because, well, now can you output any even numbers, right? Okay. And so it seems like you might be able to. You have to, and so this proof. So the first proof actually doesn't tell you. So the elegant proof actually doesn't tell you how you might get it done, though, right? See?
But it's conjecture.
But the dirty proof is the one that actually tells you how you might actually get the numbers to be even, right? So that's the problem with elegance when you're looking at like the solutions to the problems, because they're never really how you solve the problems, right? They're always like the final work of art, like the final painting after all the colors dried and everything's been done. But like you don't get to see how the paints mix. You don't get to see how the mistakes are made. You don't get to see how
Mistakes were made.
the paints were painted over and stuff. And ultimately, if you had to produce another painting, you might find it very difficult. Okay. So and so while the dirty version of this proof was so disrespected that it lost a mark, okay, it actually shouldn't have even lost a mark, even if it was incomplete in that little way, because it was only worth 3 marks. Okay, so if it was incomplete in a slight way, it would still actually get 3 marks. Okay, so or like 2.5 or something. And actually I think it was actually just marked incorrectly, but I guess the reason that the chance that it was marked incorrectly is because it wasn't easy to understand, right? It was a lot longer. So you go into all the 4 cases, and obviously, like if someone has the actual solution in front of them, it looks like looks like this one too. So they might not realize that the other one's a valid proof, and they have to check it for themselves, right? Okay. All right. Is there any questions about that? Okay, well done. So we're officially over the 12-point barrier. So
Okay, let's try the 10
we're
one,
on 14 points now. Okay.
Let's try the 10 variation.
And if you lose, yeah, let's try the 10 variation.
Which I think I have a solution for, but I don't know.